Good morning, ladies and gentlemen. I just wanted to give you a lowdown on our agenda for today, Friday, December 11th. First of all, this week we completed and we turned in the Balancing Chemical Equations PhET Lab. So if you missed that for some reason, you want to make sure you finish up. There were 4 conclusion questions. We had started the lab last week, and then we finished the conclusion questions on Monday. The second thing we did was we recorded the data from the chemical reactions lab. So that data was recorded. We have not turned that lab in yet, so that should not be submitted yet. Okay, and then the third thing is you guys completed and turned in the independent chemical reactions part 1. And that part 1 was just filling in the problem statement, the hypothesis, the materials, the procedure, and creating a data table for your lab. Okay, you don't actually have to have data in the data table. Okay, so it's a blank data table that then you can record your data in. Okay, so this week the PhET was turned in and the independent chemical reactions part 1, and that's what I checked for most of you guys yesterday or on Wednesday. So today you guys should review the materials from last week, that chemical reactions quest, or I think I called it intro. For some of you it was the slideshow. I would review the material from that. Go through your balancing equations PhET, and then you have a quiz today. So your chemical reactions quiz number 1. And then by Monday, you should have your experiment completed. If you haven't already completed your experiment, again, make sure that when you conduct your experiment, you do it one time. That's your control. And then you change one variable and one variable only. Okay? And that variable is your independent variable. So for a lot of you guys, that was the number of Mentos or the type of soda or the amount of baking soda in your cookies. Okay, right? So that's one thing, right? So then you're going to compare your results of those 2 reactions. Also, don't forget to take pictures or video while you're doing your experiment. And then next week, I'll tell you guys what to do with your data. So just record it in your data table for now. And I'll let you know what to do with the videos and the rest of the stuff next week. Okay, so last week, if you guys recall, when we did the chemical reactions intro, these were some of the key points, okay, from that intro slideshow or the quest. Okay, we talked about physical versus chemical properties, right? Physical properties, mass, volume, length, boiling point, odor, color. Hey, those are all physical properties we can use to describe something. We can also describe something using its chemical properties, and that has to do with its reactivity or its flammability. Okay, that reactivity and flammability, right? If we react something or we burn something, the end result of that is we're going to have new substances formed. So to find out if something has a particular chemical property, we would end up with new substances at the end. Okay, and then that brings us to our 2 types of changes, physical changes and chemical. In physical changes, no new substances are formed. Okay, so we have the same bonds that existed originally are still there in the end. Okay, so no new substances. Okay, in chemical changes, we get new substances, and we get that because bonds are broken. Okay, so we break bonds, we rearrange atoms, new bonds form. Okay, an example of that is photosynthesis, okay, or this chemical reaction that's up here at the top. This is how our equations are set up. When we look at a chemical equation, okay, the reactants are over here on the left-hand side in green. In this case, there are 2 reactants, okay, CH4 and O2. Those are the 2 different reactants, what we start with. Okay, and they yield or they produce the products, what we end with, and there are 2 products in this case. Okay, so the products are shown in yellow. Okay, when you look at the reactant side, if I look at something like one of the reactants, in this case methane, has 4 hydrogens. Okay, that means that when I look at the product side, I also need to have 4 hydrogens. Okay, if the equation is balanced. Okay, and when I look, okay, I see that there is a coefficient of 2 and a subscript of 2. So 2 times 2, that gives me 4. That means that there are 4 hydrogens on the product side. Okay, so whatever we start with in terms of our atoms, the number and type of those atoms that we start with is what we need to end with. Okay, so I have 1 carbon on the left. I have to have 1 carbon on the right. Okay, and that's why we balance our equations. Okay? And the reason why they're the same, okay, is because reactions, okay, cannot create or destroy matter or mass. Okay? And that's what the law of conservation of mass tells us. The law of conservation of mass tells us that mass is conserved. Whatever we start with, we end with. Okay? And that includes the number and type of each atom. That includes the mass. Okay? That includes each individual atom that we start with, we will end with. The only thing that's different, right? We start off with carbon attached to hydrogen here. Okay? We see that our atoms rearrange, and now carbon is attached to oxygen. Okay? That's what happens during a chemical reaction. Bonds break, new bonds form. Okay? And we end up with new substances with new properties at the end. Okay, when we look at our law of conservation of mass, we balanced equations last week. Okay, using our PhET. Okay, again, the only thing you can balance in an equation, or the only thing you can use to balance, are the coefficients, the numbers out front, the little subscripts, little ones. Okay, we cannot change little subscripts because that would change the substances involved in the reaction. Okay, in this case, I had to have 6 hydrogen gases in order to balance out with pH 3. There were 4 of those. 4 times 3 is 12. So there are 12 of the hydrogens on that side, 12 hydrogens on the reactant side. So I've balanced my atoms on both sides of the equation. And then this last picture just again kind of shows you the idea of conservation of mass. And when we were looking at our chemical reactions, whether we were looking at the cookies this week or the popcorn or the baking soda and vinegar, the key idea of that lab was that what we started with, we would end with. And in the case of our labs, right, so if we start with 100 grams of something, we should end up with 100 grams of product. In this case, 93 grams end up being mercury, 7 grams end up being oxygen. In our case, we ran into some problems because our products were gases, in some of our situations. And gases are a little harder to collect than solids, because they can diffuse away. And that was the problem we ran into with our cookies, and with our popcorn. The reason why our masses didn't match up is because we weren't able to collect all of that gas that was produced during the reaction. All right, ladies and gentlemen, that's a review of kind of what we've been talking about. Don't forget, you're taking a quiz today. You can go over, like I said, the materials from that slideshow, the balancing equations PhET, to review, and then go ahead and take that quiz. Okay, feel free to use any resources you want on that quiz. So look things up, make sure that you're right. You can have your notes out. Whatever you would like to help you with that quiz. And then by Monday, have your experiment conducted, and then we'll talk on Monday about what we're going to do with our results. All right, ladies and gentlemen, I hope you have a fantastic weekend. Can't wait to see you guys on Monday and Tuesday.